Good day everyone watching. Good day Sir Jeffrey Del Mundo. Today we will be giving a video presentation about the task given to us, which was exploring and explaining what are prime numbers. Let's get started. First, let us give the brief history about prime numbers. Prime numbers have been here ever since the ancient Greece. Especially the ancient Greeks have loved studying about it because they love special numbers in particular. Special numbers are those numbers which have special properties, and one of those examples are prime numbers. Prime number is a special number because the prime number can be only factored. It has only two factors, which is 1 and the number itself. And ever since Euclid established a book which is called the Elements, Book 11, he stated that in that book that there is an infinite amount of prime numbers. But it can't be found out because there are no algorithms yet. They can't establish what the prime numbers here and there yet. So after that, in 200 BC, there's a guy named Eratosthenes. He came up with an algorithm how to find prime numbers. He called it the sieve of Eratosthenes. You will get like a board, and then it's not like a board. It's a table. You will put numbers in it, and you will cross some stuff, which will be explained later.
Prime numbers are whole numbers greater than 1 and it have only two factors, which is 1 and the number itself. Prime numbers are divisible only by itself. Example, the number 6 has 3 divisors, which is 1, 2, and 3. So 1 plus 2 plus 3 equals 6. Another example, the number 28 has 5 divisors, which is 1, 2, 4, 7, and 14. So 1 plus 2 plus 4 plus 7 plus 14 equals 28. A pair of amicable numbers is a pair of numbers such as 220 and 284 in which the proper divisors of one number add to the proper divisors of the other and vice versa. Fun facts. 1 is neither a prime number nor a composite number. The only even prime numbers is 2. No prime number is greater than 5. The number that is marked in yellow are all of the prime numbers up to 100.
Why are prime numbers important? Primes are of the utmost importance to number theorists because they are building blocks of full numbers, and important to the world because their odd mathematical properties can make them perfect for our current uses. When searching prime numbers, mathematicians are always being both prosaic and practical. Also, their properties are used in cryptographic systems that we use to ensure the safety and security of electronic communications. And all numbers are built by multiplying these prime numbers together. That's why it is so important because you get mathematics from these primes, or in short, prime numbers are the root of all numbers.
How can we identify prime numbers? A prime number is an integer greater than 1 and can be divisible by only itself and 1. It has only two factors, 0, 1, and numbers less than 1 are not considered as prime numbers. A number having more than two factors are referred to as composite numbers. Prime numbers. It is fun and easy to understand what prime number is. Every prime number has exactly two factors, 1 and itself. So, each prime is only divisible by itself and 1. Let's have an example. Is 1 is a prime number? 1 times 1 equals 1. Prime number is divisible by 2 natural number, only 1 and itself, but it's divisible by 1 natural number, which is 1. So it's not 2 natural number. It has 1 natural number. So 1 a prime number? Definitely not. So, I have one example. Is 2 a prime number? 1 times 2 equals 2. So, number 2 is have factors 1 times 2 or 2 times 1. So, number 2 is divisible by 1 and 2. Therefore, it is a prime number.
Mr. Industrial ba when I tell you what is the fastest way to find a prime numbers using prime shaping by Eratosthenes? Why number 1 is not prime numbers? Because 1 is divisible by itself and it is not greater than 1. Let's proceed in number 2. In up to 100, number 2 is the only even number that considered a prime numbers. Here we can use prime shaping and how it works. All numbers that multiples of 2 is not considered a prime numbers. For example, 2, 4, 6, 8, 10, and so on. If the numbers ends in 2, 4, 6, 8, and 0, then one of its factor is 2. Number 3. Number 3 is prime numbers because it is greater than 1 and is only divisible by itself. Next, the number that are not prime numbers is all the multiples of 2. For example, 6, 9, 12, 15, and so on.
In today's society, most of the people do not know that we currently use prime numbers heavily in a lot of things, and that includes how manufacturers remove harmonics on products which really save the produced stuff. Humans also use them on modern screens to define the colors through internal part calculations, and not only we humans use them but animals and insects as well. Cicadas, an insect which times their life cycle through periods of prime which are very specific and synchronized for their own survival. Among those said examples are a hidden key to how humanity use social security as of today. It's hard to break a code made up by the product of two numbers since the combinations are really difficult to encrypt. That's why online security in today's society is very developed, and that's all thanks to our prime numbers.